Hey guys, in this video I'm going to go over an explanation and application for every 2D constraint in less than 10 minutes. So really quick before we dive into the constraints, I'm going to go over a little bit of a preamble. Whenever we're drawing in a 2D sketch, we use constraints to keep our sketch from destroying itself whenever we move things around. So with this rectangle we have a we have a couple of pre-existing constraints already, but these constraints will help us whenever we move something around. It'll keep things like perpendicular or horizontal or orthogonal, all of that fun stuff. So here we have some tangents constraining here, and these are all needed for these types of shapes. For lines, you don't really see much of a constraint, but once you start connecting lines, you can hover over the point and you can see some constraints in there. To show the constraints, you press F8. To hide them, you press F9. Once again, F8 and F9. And that's pretty much all of the preamble I wanted to give. So let's hop into the constraints themselves. Okay, jumping into it, we're going to come across our first constraint, which is the coincident constraint. As we see here, we have a circle and a line. I'm going to skip over that big blob of text, but pretty much this is going to connect our points to points or points to lines. So as an example, I'm going to click this line point and put it on this line. And so, oh my goodness. So here, this point is going to be anywhere on this line or the path of the line. See, as we move it over here, we can see it's not on the line anymore, but it's going to follow the path of the line. So that's nice to have, but if you want it to be exactly on that point, you could do point to point. So now, no matter where we move this guy, it's going to be exactly on that point. You can still see that this is going to be intersecting with that line here. So that's good to know. Applications, you could see this. I could see this being used on some like basic ones. So like the center of a circle on a line, you line that up. If you even once, you can even line it up to the middle point of a line, like this. And so now wherever you move this, the center of the circle will be in the center of the circle will be on the center of the line, I guess. Yeah. So that's nice to have. All right. Next we have our collinear constraint, which is this guy right here. This one's going to be a line to line. So click a line, click another line, boom. You can see that it's in the same path of the line. No matter where you move it, it's going to just be like pretty much parallel, but on the same path. Some applications for this is, let's say you're building you're building an organizer for a drawer, and you want to make sure everything is aligned. Like each little box in a drawer is aligned with the edges. So you go ahead and click this guy, and then boom, these guys are aligned. And let's say we have a couple of them, so boom and boom. We're gonna do another one over here. Boom, those are aligned. Do this one. Boom, those are aligned. But because those were already aligned, we get this constraint error, just saying that it was over constrained. And just like that, and then you can wiggle these around, make sure like whatever design you want looks decent, just like a spiral square, I don't know. But yeah. Alright, so now we have the concentric constraint. This is going to be a curve to curve constraint. So what it's going to do is you click a circle or an arc, you click another one, and it puts them matching up on their center points. This is mostly used for like through holes or like any sort of like screw holes you want to make, or just like making sure things are aligned properly. But let's say I'm printing like a board, like a PCB board or like some sort of a shelf or something, and I want a screw hole along like this curved edge I have. So I go ahead and click the hole size that I need, and then I click the arc, and then I can extrude this hole once I finish the sketch. So now we have the fix tool. Fix tool works on curves, points, and lines. So if we click a curve, the curve still stretches, but if we want a curve to stop stretching, we can lock one side. Now that side is locked, but the other side is still unlocked, and so you're going to have to lock that other side for a full constraint. And for lines, let's say we just lock this middle point of this line. It moves around that center point where we locked it. For this one, I'm gonna lock the entire line. So now this center point can move around like this way, but it's gonna be following the path of that line. And if we lock it the last way, which is the center point, then center point clearly doesn't move, but these legs do. A real life application of this would be, let's say I have like a big drawing, pretty elaborate. This circle is pretty important. I measured it out a couple times, but I want to move this line further up, almost tangent. But whenever I try to do that, I kind of shift the circle a bit, that ruining the whole thing and my measurements. So what I gotta do is lock the circle. Now I can shift this line just fine without moving the circle. So our next constraint is going to be tangent. Pretty straightforward. It's going to be, you're going to get a line tangent to a circle. So it only works with line to curve. Some practical applications, I can see two. First would be trying to round out some edges. Click the circle twice. Click the edges that the circle resides in. You get a nice little curved edge if you cut these guys out. Or you get a center point for a through hole, just like that. Next application would be you have this weird shaped thing and you want to get a nice curvature to these bounds. You just make a random circle, any size, then you tangent it for these, and the circle is unbound, so it'll automatically reshape itself to fit the bounds you give it. Then you have the center point, and you can make a nice little curve like that, or a through hole, just like I said before. So for this next constraint, it's going to be the smooth constraint. This is mostly used for kind of exactly what the name implies, making things smooth, just like that. It's a curve-to-curve constraint. It is a little finicky with the arcs, so I usually would just do them on splines whenever I'm looking to make anything organic. It removes pretty much all the sharp edges that doing things manually would normally create, and it's just makes it look a lot better whenever you apply the smooth function to it, just like that. So for our last two constraints, we're going to go over symmetry and equals. So for symmetry, pretty straightforward. You're going to make things symmetrical. So you're going to select three things. You select the first two things, which are the sides, and then you select the third, which is the symmetry line. So here we saw the two circles. Now they're both the same size. Wherever I move the left one, the right one follows. Shape follows as well. If I move this symmetry line around, the left side follows as well. That's some cool stuff. If we apply it to some lines, something else happens. Left side, then, oh, that's the wrong tool. Left side, right side, middle. Now we see that the two lines are symmetrical, but there is one difference. The lines are not the same length, unlike the circles. So if you were to make them the same length, you would use the equal tools, or the equals tool. Click the left side and the right side, and then boom, they're now equal lengths. A real life example of these utilities would be, let's say we have a couple of different lines here. Actually, let's use two lines for now. And I want to measure the angle of a certain point to a certain point, but I want it to be centered properly, so symmetrical. So I click the left side, and I click the right side, and then I click the middle, and then boom, they're now symmetrical. I want to make sure that those lines are equal to each other, so I make them equal, just like that. And now whenever I make a change, let's say I want to adjust the how far this line goes, let's make it 60 degrees. So the 60 degrees is also updated on the other side, which is nice. Let's say we have a bunch of lines over here on this side, and they all kind of range from length to length. We can use the equals tool, and we press down the control button, and we can apply equals to every single one of them and share the length between them all. So if one updates, they all update. Whoa, big weird. But yeah, that's everything. If y'all like the video, drop a like. Thanks and goodbye.